Alright folks, so in this video I'm going to talk about simultaneous equations. Now simultaneous equations are one of these things that a lot of students really don't like because they think they're really hard, but they're actually not that difficult. The problem with a simultaneous equation is you need to go carefully through it because there's quite a lot of steps and you need to be sure that you don't make a mistake. The most common problem that students have with simultaneous equations is sign errors or silly little multiplication or addition mistakes. It's not the actual maths itself, it's really just simple little mistakes that they make, okay? So anyway, that's what we're going to be doing. Now before I go any further, I want to talk briefly about, well, what is the point of a simultaneous equation? So if I've got an equation, 2x plus 3y is equal to 9, and then I have another equation, say 4x plus y is equal to 13. These are both linear equations. They are equations of lines. So if I've got my xy graph, my Cartesian plane, I could, now this isn't the actual line, but I could plot one of these points, and then I could plot the other point, or points, sorry, lines. So if I actually get points for this that are on this line, plot them, and then I get my line, and do the same for the other one, find points that are on it, and I get my other line. If I get a simultaneous equation, I am finding this point here. It's the point of intersection of the two lines. So that is the point of simultaneous equations. It is to find points of intersection. That is why we do them, okay? That is the reason. Now, there are 4 steps that you need to remember to do simultaneous equations. If you carry out these 4 steps, you can solve them. Step 1, decide which variable, i.e. letter x or y, you want to remove first. Step 2, multiply one or both lines so that the variable we want to remove has the same number in front of it for both lines, but with the signs different. This is important, okay? The same number, but the signs are different. Step 3, add both lines to remove our chosen variable. And then step 4, add both lines to remove our chosen variable and solve for the remaining variable. Okay, and then step 4, sub back in to get the other variable. Okay, so let's do this example here. 2x plus 3y equals 9. And 4x plus y is equal to 13. So step one is decide which variable we want to get rid of. Do we want to get rid of our x's first or our y's first? I'm going to get rid of our y's first. Decide variable. So I've decided I'm going to get rid of y first. Step two, multiply. Same number, different signs. So I have line 1 and I have line 2. I want to get rid of my y's, okay? So I need to have a 3y in both of them. I've got 3y here, but I've got 1y here. So in order to get rid of the other y, I need to change this into a 3y. But more importantly, I need to change one of these into a minus 3y. So how I do this is I'm going to leave the top line as it is. I'm not going to bother to change it. 2x plus 3y is equal to 9. The bottom line, if I multiply it by 3, I'll get a 3y. But I don't want 3y, I want minus 3y. So I'm going to multiply it by minus 3. So 4 times minus 3 is minus 12x. Y by minus 3 is minus 3y. 13 by minus 3 is minus 39. Okay? So step 3, add lines and solve. Okay? So we added two lines. Minus 12 plus 2 is minus 10. X. 3y minus 3y is 0. Minus 39 plus 9 is minus 30. So minus 10x is equal to minus 30. But I want to know what 1x is equal to. So how do I change minus 10 to 1? Well, to change 10 to 1, divide by 10. But that would give me minus 1x, and I want it to be plus 1x. So how do we change this from a minus to a plus? You have to remember your rules for integers, folks. When we multiply, or in this case divide, a minus by a minus, we get a plus. Alright? So minus 10x divided by minus 10 will give me plus 1x. And then minus 30 divided by minus 10 is going to give me, well, 30 divided by 10 is 3. Minus 30 divided by minus 10 is still 3. So there we have it. Step 3 done. We added both lines and we solved. So we now have one of our variables. We now know what x is equal to in this simultaneous equation. Step 4, sub in to get y. So I sub x equals 3 into either one of these two lines. Okay? Doesn't matter which one. I'm going to sub it into the second one. Okay? So we have 4 by 3, and do it like this, folks, okay? Anywhere I had an x, I'm replacing it with a 3, so I write that as the number I'm replacing in brackets, okay? This is really important that you do this. These little steps, using brackets when you substitute in, really helps reduce the chance of you making a mistake, okay? The most common mistake you will make doing these simultaneous equations is you get your signs wrong. And then the second most common mistake is like you multiply 2 by 3 equals 5 or something really stupid like that, okay? Like it's a simple honest mistake, but and when you've got lots of steps like this, it's very easy to do, okay? So that's why something which might seem a little dumb, but something as simple as, oh, write it in brackets really helps, okay? So 4 by 3 is 12 plus y is equal to 13. So we're getting there, but I don't want the 12 here, I just want y on its own. So how do I get rid of this 12? Well, do the opposite. If this is a plus 12, subtract 12. Whatever I do to one side, I must do to the other. So I subtract 12 from that side. So 12 minus 12 is 0, and 13 minus 12, y is equal to 1. So our final answer, x equals 3, y equals 1, means that if I were to graph these two lines on a xy Cartesian plane, they would cross at the point 3, 1. And there we go. All right. So that is basically it. Now I'm going to do one more example. This time a slightly more complicated example. Not much. Only more complicated in that we have to multiply both lines. Okay. But it's really not that hard. Okay. 4x minus 3y is equal to 23. 2x minus 5y is equal to 8. Okay. So the first thing we have to do is decide which variable we want to get rid of. Now, I could get rid of the x first really easily, but I'm choosing to get rid of y first to show you how we would do this if it was a more difficult question. Okay, so I want to get rid of y. So step 1, choose variable. Step 2, multiply. So we get same number, different sign. So, and it's a good idea to label your lines like this. So we have a -3 and we have a -5. So the obvious thing to do is to multiply these both so that we get 15, because 3 by 5 is 15. That way they'll cancel out easily. Okay. So I have to multiply this line to get a 15. Okay. Now, the other thing I have to remember though is that you're going to have different signs. These are both minuses. So I'll need to change one of these to a plus. Now how you do that is one of the two lines, but only one, we multiply by a negative integer, by a minus, okay? Because minus by minus gives me a plus. So I'm going to multiply the top line by 5. So 5 by 4 is 20x. 5 by minus 3 is minus 15y. 5 by 23 is 115. Yeah. Yeah, 115. So the bottom line I got to multiply by -3. And you'll see why. -3 by 2 is minus 6x. -3 by -5. Well, 3 by 5 is 15. Minus by minus is 8 plus 15y. So we now have what we were looking for. Same number, different signs. And then -3 by 8. Well, 3 8 is 24, so this is minus 24. So 20 minus 6 is 14x. They're gone. 15 minus 24, 91. Now I don't want 14x, I want 1x. So I divide both sides by 14. Okay? And I get x equals to 6.5. Now you'll be looking at say, I made a mistake. It's not a whole number. I never said this has to be a whole number. 6.5 is a perfectly valid coordinate on an XY graph. This is correct. You need to get over the issue of it has to be a whole number. It doesn't have to be a whole number. Okay? So step 3, which you've now done, we add our lines and solve. That's what we just did here. We added 2 lines together and then we solve for x. Step 4, sub in. Okay? So subbing 6.5 back into one of these. I'm going to, sure, we'll sub it into the top line. It doesn't really make a difference. Alright, so 4 by 6, 6, 12, 18, 24. Okay, 4 by a half, well what's a half of 4 is 2. So it's 24 plus 2 is 26. Now obviously you could use your calculator if you want to. Is equal to 23. So we're getting there, but I don't want this number on the left hand side. I only want my y, so I need to get rid of it. How do I get rid of plus 26? We subtract minus 26. Okay, so 26 minus 26, that's gone. And we're left with 23 minus 26. Well, what is 23 minus 26? It is minus 3. So minus 3y equals minus 3, but I don't want a minus 3y or plus 3y, I want y. So how do I get rid of this minus 3y? How do I change that to 1? Well, if I divide 3 by 3, I get 1. If I divide minus 3 by minus 3, I get minus. Or I still get plus 1, okay? Because minus by minus is a plus. And then we divide it, whatever we do to the left hand side, we do to the right. So minus 3 divided by minus 3 is also 1. So our answer is 6.5 and 1. So if I were to plot these two lines, 4x minus 3y equals 23, find a couple of points, draw a line to connect them. Find a couple of points, draw a line to connect them for the other one. Where these two lines would cross would be at the coordinate 6.5, 1. And that is how we do simple simultaneous equations. I hope these make sense. Keep doing them, practice them. They are not that difficult. You just need to practice them. And if you practice them and if you're careful, you will be fine. All right, so take care, everybody. Thanks a lot, and talk to you soon.